In a previous video, we proved that the opposite angles of a parallelogram are congruent. Now we're going to prove that the opposite sides of a parallelogram are congruent. And I want to walk you as much as I can through a thought process here. And I think the best thing to do is to take your parallelogram and just say, you know what, they gave us A, B, C, D, and we know it's a parallelogram. Good place to start. A lot of things we could label. We could say this is parallel to this is parallel to that, all kinds of great stuff. I'm going to go a little crazy on you here. And I'm going to eventually, at the end, and so are you, you're going to get to a point where you're going to say that BC is congruent to AD, because opposite sides are going to be congruent by the time we're done with this. And you're also going to say that AB is congruent to CD. And in order to get there, we're going to have to put some other things in. How do you know? Sometimes when you're doing a proof, you just experiment. So hang with me and draw this. We're going to draw one of the two diagonals. If you want to draw both diagonals, it'll clutter your picture. It's not mathematically wrong, but it's not going to be helpful at all. So let's grab a blue pen, or whatever color pen you want to grab, and we're going to start labeling some things. Now I want to show you where this is going. Again, I'm going to try to take you through my thought process. This triangle is congruent to this triangle. I mean, you can look at it and tell. But again, the purpose of a proof isn't like, well, I knew that. It's let me develop the thinking I need for more complicated things. So we're going to say that this triangle is congruent to this triangle. And in order to do that, we have to have some triangle congruence. Now, back in the day, we had a list of triangle congruencies. Triangle, spell it right. Triangle congruencies. These are ways to prove that two triangles are congruent. We had side, side, side. All three sides are congruent. We had side, an angle in between them, and a side. We had an angle, a side, and an angle. We had an angle, a side, nope, an angle, and a side. And the obvious one that spells a word you shouldn't say is not going to work. It isn't. However, it does work if you are dealing with a right triangle. That would be a hypotenuse leg. But that's technically a side angle side issue because your right angle would be in between them. So those are our options. We're not going to deal with hypotenuse leg. And I'm going to try to get two triangles equal to each other using one of these things. Well, okay, first of all, side, side is out. Like side is so not an option right now because I don't know that BC and AD are congruent or AB and CD, right? Because like that's what we're trying to prove. By the time we're done, that's where we're going. We ain't there. Okay, so side is not going to work. Side angle side isn't going to work because, again, I'm going to need two pairs of sides in order to do this, and don't know that. So he's out. We can pick one of those. I'm going to pick angle, side, angle. You'll see where this is going in just a minute. So let's start by labeling in red the fact that this angle is congruent to this angle, and we're going to write that down. And we're going to say that angle A, B, D, and that looks like I meant for it to be a right angle. It is not necessarily. Angle ABD is congruent to angle CDB. And while we're at it, by the way, this is step one. While we're at it, we're also going to label another one, and that other one is going to be purple and double swoosh. Whoop, whoop, and whoop, whoop, there. And we're going to do that one as well. Now, how do we know that? I'm about to tell you how we know that, and you'll figure it out too. CBD, angle CBD, is congruent to angle CBD, corresponds to ADB. CBD, ADB. And the reason for both of these is the fact that, hang with me now, we have parallel lines that are cut by a transversal. And because these parallel lines are cut by a transversal, alternate interior are congruent, and we can do the same thing over here. And these red ones are alternate interior. So we know this is true because I'm going to put my reasons in red. Alternate interior angles are congruent. Now, if you want to back up an extra step, which I probably should have done, and I actually want to be really specific about this and start here. We're going to let that be step 2. Sorry. We're going to say that BC is parallel to AD, and AB is parallel to CD. And the reason for that is because it's a parallelogram. So this is a definition of a parallelogram. So we're going to justify like everything, okay? So we know that because that's what a parallelogram is. Now that we have parallelogram, we know these opposite sides are parallel, and therefore we can start talking about alternate interior angles. Now, this next step is going to look a little redundant, but I'm going to write it anyway. Let's think back. Angle, side, angle. Sound familiar? Angle, angle, side. You can do it if you want to. I choose not to. I'm going to go with angle, side, angle. I'm going to say that side BD is congruent to side BD. That looked stupid. Duh. I hear you, but we're going to justify everything within reason. And this is the reflexive property of equality. Put an equal sign if you like. There we go. There's the reason for that. Here's what we have now. We have an angle, a side congruent to itself, and another angle. And for that reason, we will be able to say that two triangles are congruent. We'll be able to say that ABD is congruent to, now let's match them up. A corresponds to C. B, red swoosh, corresponds to D in the other triangle, red swoosh, and then B. And I know that because of angle, side, angle congruence. Ah, nice. Okay, well now that we've done that, we've been able to say, well, this triangle is congruent to that triangle. We've matched up the corresponding parts by putting the letters in the right place. So now we're going to go one step further, and we're going to say AB is congruent to CD. That's what I was aiming for anyway, right? And I also know that, let's not use a comma. Let's use another one. BC is congruent to AD. And I know all of that because, and this is going to get a little wordy, I just proved that two triangles are congruent, so therefore their corresponding parts must match up as well. So corresponding parts of congruent triangles are congruent. C, P, C, T, C. Let's write it like that from now on. Therefore, final answer. Therefore, opposite sides of a parallelogram are congruent. I'm abbreviating.